All right. Can you hear me now? Can you hear me now? Yes. Yes. Can you hear me now? I was just saying good evening, everyone. Sorry for starting later today. As some of you just mentioned, we had in our school, we had Paris evening, and that postpones everything. That postponed my dinner, that postponed my nap, that postponed just everything, okay? But here I am. Here I am. I'm just checking. I see that the streaming in Twitch works well. I see that the one in YouTube works well. I see people talking, people participating. That is lovely. That really helps me and encourages me to continue, of course, because the whole idea is to be useful for you guys, to help you with your science. I even have some people already asking about helping with maths. I have to say yes, unless it is key stage 5. I think I can help with maths. What I cannot help you with, and I think is obvious, I cannot help you with your English, or I cannot help you with your music. Music has always been something not very good for me. But apart from that, math, science, if you have any question, I can solve it. Okay? So, I said the 100 humans, guys. The 100 humans will win. Of course. The gorilla will get tired eventually. Still, the microphone is not working? Let me check. Hello? Hello? No, it's working, David. I have myself in the camera. All right. Cool. So 100 humans. 100 humans, they are going to win because the gorilla will get tired and the humans can make a strategy. End of the story. I don't know who you are, but AK-47 the King. You sound like someone who is playing you sound like someone who is playing Call of Duty. Can you do motion today, please? And fitness, and we have tests soon. Okay, let me do a quick poll. What do we have now in here more? Key stage 4 or key stage 3? Let's have a quick poll, okay? For all the spectators we have, let's have a poll. What do we have more? Key stage 4 or key stage 3? Depends on what we got more. Okay, key stage 4. 1. Hello, Alan. You see, I knew that you are playing Fortnite or Call of Duty. No, David, you are key stage 3. Key stage 3 is here 7, 8, 9. And then 9, 10 is key stage 4. Okay? Mr. Romero's left ankle. Who is that? My left ankle is in here. It's in here. You're not my left ankle. What is that use? Alright, it's a funny one. For now, key stage 4 is winning, okay? For now, key stage 4 is winning. Key stage 3. Alright, let me see if I can do 10 minutes each, okay? Let's see if I can do 10 minutes each. Meanwhile, let me see if I can find also a beautiful exam question for energy. Just one quick one, okay? Meanwhile, you are criticizing me there just for a little bit. I will look for a beautiful exam question. I will try something that is relevant for all the students. Okay, I think this one is a bit easy, I have to say, but could be relevant. And then David wants motion. Let's get him motion. Yes, okay, fine, David, fine. Do not worry. I think we see this one. Yeah, fine. Yes, we see this one in key stage 3 too. Okay, so I got 2 questions that we see in both key stage 4. And then, all right, let's go with these two. Let's go with these two. Okay, so let's jump to the questions. Ooh, Japanese. That's really something I cannot help you with. Okay, all right. So let's go to the lesson. Now the camera is here, and now I want to share. How do I share a document? How do I share with you a document? Yeah, this is my arm. This is my arm because I'm gonna write in here in 1 second. Relax, chill, chill. Take your chill pill, please. Take your chill pill. All right, I can share an image, but not a document. A bit silly, I would have to say. That's a bit silly. Let me see if I can share a document. No. Meh. Sorry for those who are waiting for. I'm trying to be as quick as possible. How was your day anyway? Did you have all of you a good day? Yes, no, no, yes. I hope you all had a fantastic day. Wait a second, I will move back to this one so you don't see my arm. People are getting a bit tense, especially my lesson. Nah. I thought it was gonna be. Why did you think it's gonna be bad parents evening? You are all very good students. The practical was good. It was about electricity. It was nice. It was really nice. If anyone who has done a stream before, you know how to get to share a document in OBS, I would really appreciate it. It would be really helpful. Really helpful. Because otherwise I have to do question by question and it has to do an image and it's very annoying. Because I need to go to the document, cut the document. It's just very slow. And if I could just share with you the exam pages, that would be much easier. Okay? All right. This is going to be question 1. Look how slow this whole process is. Question 1 is very slow. But you should be able now to see the question in 1 second. Now. Yes. Waiting music. Oh, yes. I could put music. I don't know why I forgot. Question 1. Let me put some jazz. I know how to do it in YouTube but not in Twitch. Okay, maybe we can have a chat another time and you explain to me how we can share a document. Because I know how to share an image with you guys, but not... I don't know a document. Come on. Why is not coming? Screenshot. Yeah, that's exactly what I did. And I'm losing spectators as we talk. I'm getting frustrated. Because people they are waiting to receive their lesson. Oh, come on. No, take your time. No, we are here to talk about science. All right, here is the question. Finally, oof. Oh, it's difficult. This was difficult. I'm pretty sure that professional streamers, they can do this better, but for me it was difficult. All right. So let's start talking a little bit about energy, giving you a bit of introduction, okay? Energy is the capacity that a body has to perform a work. And when I mean a work, I'm talking about the general term work. If you think about all the activities you do, talking, eating, moving around, sleeping, all of them requires energy. They are all sort of works, okay? And the capacity to perform those works is what we call energy. And the good thing about energy, or the interesting facts about energy is that it can be transferred. I can transfer energy from my body to another body, or from one object to another object in many different ways. It could be mechanical. Mechanical is just, for example, lifting up something. This is a mechanical transfer of energy. It could be also waves. It's another way of transferring energy. What will be electricity is another way of transferring energy. So we have different ways to transfer energy. And apart from that, we have what we call different energy stores. What is an energy store? It's a manifestation, it's a different manner that energy can appear or can interact with others, okay? For example, the energy that is related with all the object that moves is called kinetic energy. The object that is related with objects that they have heat is called thermal energy. The energy related with any sort of sound is called sound energy, etc., etc., etc. Or in this particular case, like Santi is mentioning, gravitational potential energy is the energy that all the objects, because they are above the ground, they have energy. So my pen in here has gravitational potential energy. And as soon as I'm not holding it, it falls because of that gravitational potential energy. All right? And energy always transfer. And when it transfer, it is conserved. And when I mean conserve, it doesn't mean that it votes for conservatives. It's not into politics. It means that the total value of the energy is not changing before and after. Okay? Anyway, let's see at this transfer. So we have a person bouncing on a trampoline. The boy falls from the position in the figure above towards trampoline. Complete the sentence. So as the boy falls, there is a decrease in his... No, not politics. It's called conservation of energy. Anyway, as the boy falls, there is a decrease in his gravitational potential, because first he's at this height and he ends up being at this height. So he's getting lower height, lower gravitational potential energy. And also, as he's falling, he is accelerating. And when he's accelerating, his speed increases. Therefore, kinetic energy. Now, for those who are already doing key stage 4, do you know what are the factors that gravitational potential energy depends on? What are the factors that they change the gravitational potential energy of an... Thank you, Santi. Of an object, of a body. What does it depend on? I will give you one, and you try to give me the other ones. The height. That's the most important. The higher the object, larger the gravitational potential. Easy. Mass is another one. Heavier the object, larger the mass, larger is the gravitational potential energy. Okay? But there is one more factor. No? Well, give a twist. give a twist. How do we call the acceleration that makes you fall? No. All the objects that, yes, gravity. Gravity is a sort of acceleration that makes all the objects to fall, okay? So these are the three factors gravitational potential energy depends on. So when we put all of them together, that gives us the formula to calculate gravitational potential energy. So gravitational potential energy, that can be simplified as GPE, not GTP or GPS, GPE, gravitational potential energy, okay? What is MP? No problem. Is equal to the mass times the height times gravity. That's how we calculate how much is the gravitational potential energy of an object. Doing the mass of that object times the height times the gravity. Okay? And one of them is always the same. The gravity on this planet is a constant, it's always the same. We say that G on Earth is 9.8 meters per second square. Like all accelerations, meters per second square, that is the unit for acceleration, okay? So the gravity on Earth, we say that it's 9.8. Some people, they like rounding it to 10. If you're going to round it to 10, make sure you mention it in the exam, okay? And the other energy that we mentioned in the activity is kinetic energy. For those who are not into Greek language, which I don't know why you are not, because you should, kinetic comes from the Greek kinesthesia, that means movement. That's why it is not called movement energy or moving energy. It's called kinetic because the name comes from the Greek language, kinesthesia, movement. Okay? And kinetic energy. There are only two factors this time that changes, or better say, there are only two factors the kinetic energy depends on. Let's try to find it out. So now in the chat we have my left ankle and my right kidney. I don't know if this is a statement that you are just trying to take my organs. Yes, I love Greek. I love Greek language. There are many words we use in science that they come from Greek language. But now the question is not that. The question is, what does the energy of a movement depends on? That is the question. Think about the energy that will transfer a car crashing on your face. What will that energy depend on? If you think about it, it's quite straightforward actually. Come on guys, use your brain. Use the brain that God gave you. Use the brain that God gave you. Speed and mass, exactly. Speed or velocity, same in this context, same. Doesn't matter. And mass, okay? Electricity, no. Yes, you have a brain. Of course you have a brain. Otherwise you wouldn't be able to have a chat in here. Look, think that is not the same being hit by a car that is moving at 1 miles per hour or a car that is moving 100 miles per hour. It is really not the same thing. And then it's not the same being crashed or stop a car with your face if the car is like a toy car or the car is like a proper 4x4 car. Okay, it's obviously not the same. So I would set the chat. Oh, sorry, the music. A bit of music. So yes, the two factors that changes the kinetic energy of an object is mass and speed. Okay, and when we put this together, give us the formula for kinetic energy. That is represented with the letters K, E. I know some people say, can't we use, instead of K-E, E-K? You can. You can. It's fine. But I prefer K-E. I don't mind. But you can use, instead of K-E, you can say E-K. That's fine. Whatever makes you happy. The music does not have copyright, okay? Just to let you know. It doesn't have copyright. I found jazz music without copyright, alright? Anyway, how do we calculate the kinetic energy? AK or KA, doesn't matter. Is the mass times the velocity squared, and that divided by 2. Okay, that's fine. I have seen, or you can say, if you prefer, 1/2 times the mass times the velocity squared, if you prefer like that, okay? No, you will not get marks for writing the formula. You will not get marks for writing the formula. Sorry. Unless the formula is not given. What you need to be able to do is you need to be able to rearrange the formula to get from the formula whatever you want. You have physics tomorrow. You are doing well being here. Okay? You need to be able to rearrange whatever you want from the formula. So they can ask you, using this formula, to get the mass or to get the velocity. And you should be able to find it out. Okay? There is another formula that we need to know, but I will show you in the exam question. Just give me a second. There was a moment that we had 14 people in here, and now they are all gone. What did I do? Really, what did I do? What did I do wrong? That I lost so many people in just 1 second. Again, 14 people. Okay, I don't know what's going on. Is this fluctuation normal? Is it happening to everyone? Anyway, doesn't matter. Even if we are just one person, we will be here learning about physics and science in general. Let me show you another question for energy, okay? In this case, is elastic energy, the one I'm going to share with you in a second. Question 2. Switch counter container B. Okay. Okay, well, now we have even less. What can you do sometimes? Okay. Look at this question now. Alright, and let me enlarge it a little bit. Hi, sir. Can you remember the compass nail experiment for tomorrow? Compass nail experiment? What do you mean with that? Sorry, can you remind me, please? What are you talking about? Alright. Can you all read the question properly? Yes, I think like that is fine. Alright. Yep. Okay, fine. So we have, as the boy lands on the trampoline, each spring stretches 0.015 meter. Okay, as I always do, for me, is my routine to always collect all the information that they give to me. So I know that the change in the extension is going to be 0.015 meter. That is going to be the change in the extension. Remember that springs, they can get larger, but they can also get smaller. In this case, it's saying that the spring stretches, well, stretches in this case, 0.015. Because if it was compressed, it would be negative, okay? God, exactly, quarter past. That's fine. You have been here for very long. We have the spring constant, which is represented with the letter K, is 120,000, wow, Newton per meter. And they ask me to calculate the energy stored. And they give me the formula to calculate the elastic energy. 0.5 times the spring constant times extension square. All right, so for those who are doing physics combined, or you're doing physics foundation, this is an example of question they could ask you. But if you're doing separates, they will not ask you this. In any case, they will ask you to find the extension, but they will not ask you this. Yeah, the units for energy is joules. Remember, energy, joules, spring constant, Newton per meter, and extension, meters, okay? So basically, what you need to do, and that's why I'm saying they will not give you this question in the exam, or if they do, just stand up and scream, because it's very easy, easy peasy lemon squeezy. You just need to substitute the numbers. EE is equal to 0.5, or 1.5 if you prefer, times 120,000, times 0.015 square. Careful those who are not very good with math, because the square is only for the extension. Don't leave the square at the end, because in that case, some of you, what you will do is you will square everything, and that is not what the question is asking, okay? What they want you to square is the extension, and you just continue it here, and you just find out the elastic energy. So we have seen three examples of different ways to calculate different energy stores. Notice that the three cases we are talking about energy. But in one we were talking about gravitational potential energy, in the other one we're talking about kinetic energy, and in the last one we're talking about elastic energy. The three of them, they are energy, and they still have three different formulas to calculate their value. Three different formulas to calculate their value. All right. Talking a little bit about motion. You need to do your Duolingo daily. Learning languages is very important. Imagine we have a graph that is saying distance, and here is saying time. And we have a graph that is here, 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 and up. Okay? Those who just joined, this is not the graph for changing the state. Okay? This is the graph for motion. Question. Imagine that this is A, B, C, D, E. Okay? Just to name it. What is the meaning in terms of the motion when we have in a graph distance versus time? What is the meaning of B and D? What is happening in terms of the motion in B and D? No movement. That has another name. That has another name in physics. Starting with S. Starting with S. Stationary. Very good. So B and D are stationary. The car, the person, whatever object we are talking about. With the graph, distance versus time, the graph is flat, is stationary, meaning no movement. Now, what can we find out from the gradient of the graph? What can we find out from the gradient of the graph? If they give us a graph, distance versus time, what can we get from the gradient? No, not acceleration. Meh. Okay, there is a bunch of lines, no problem. Let me make it more clear for you, okay? Distance, time, and now only one line, okay? Only one line. If the graph is distance in the y-axis and time in the x-axis, what can we find out from the gradient of the graph? Someone mentioned it earlier. I will not say who, but there is a person who mentioned it earlier. Almost. No, because change in velocity would be acceleration. It is actually just the speed, okay, or just the velocity. All right. So from the gradient of a distance time graph, what you obtain is the speed. Guys, do you remember which one was the formula to calculate the speed? Just the general formula to calculate the speed. No. Speed is distance divided by time. No. No, Santi, no. Distance divided by time. Let's talk about the units. What are the units to measure the time? And what are the units to measure distance? Because once you find those two, you know what are the units for speed. Santi, you are a bit cook. You need to revise more physics. Just join to my stream more often. Seconds for time and meters for distance. So the speed is measured in meters per second. Let me tell you this, guys. From someone who used to mark AQA exams, if you say that the speed is miles per hour, the person who is marking your exam just stops and say, this person has no clue, this person is not studying, this person is going to fail. You are a top man, Santi. Go to bed and sleep. We are all going back soon because we need to be fine for school tomorrow. I mentioned earlier that we can get the speed from the gradient, but I assume that you know what is the gradient. Do you know how to find the gradient? 2 points. Imagine we have 2 points, x2, y2, and we have b, x1, y1. Do you know how to get the gradient from those 2 points? No. No. Not really. Not really. No. Anyone else apart from Santi? No. Almost. You are getting closer, but not exactly. You're getting closer, but not exactly. You're getting closer, but not exactly. Come on, guys. Use your brain. We are almost there. No. Wait a second. Yes. N8 waffles 5221. Well done. It is actually change in y divided by change in x. Or if you prefer, because you don't like changes, you are like me, you are very traditional, y2 minus y1 divided by x2 minus x1. Okay? Now some people might be thinking, and what 2 points do I get? Doesn't matter. Just the 2 points you hate the most. 2 points that you like the most. Doesn't matter. Any 2 points in the graph will do the gradient. Important. We are talking about a straight line. Alright? If it is a curve or is any other shape, it doesn't work like that. But if the graph is a straight line, yes. If the graph is a straight line, you can find out the gradient like this. And by the way, this is important for maths, for chemistry, for biology, and for physics. If you don't know how to calculate the gradient, it's something that you need to revise. Okay? So this was about motion, answering David's request. And now I want to talk briefly about 2 different kind of way to set up circuits. Okay? Circuits can be set up in 2 ways: series and parallel. Series and parallel. Imagine I have question. This is a cell or a battery? What is this? A cell or a battery? I mean these two, okay? Those two together are cells or battery? Exactly. Remember that the difference between a cell and a battery is that a battery is more than two cells connected. So this is a battery. And you know that all the batteries, like the cells, they have a plus and they have a minus. Where does the plus go and where does the minus go? In the long one or in the short one? Where do I put the plus? Long or short? In the long one or in the short one? Where do I put the plus? The symbol plus. Yes, plus in the long, minus in the small. Plus in the long, fantastic. And in what direction is the current flowing? Is it going from positive to negative or from negative to positive? In what direction is the current flowing? That is also important. Imagine we have the circuit, and continues in here, and comes back in here. Where is the electricity going? From plus to minus or from minus to plus? Sweet dreams. God bless you. Positive to negative. Yes. It goes from positive to negative. Okay? Alright. So imagine that, and now I tell you, we're going to set up the ammeter. The ammeter, how do we set it up? In series or in parallel? The ammeter is always set up in a particular way. The ammeter is always set up in a particular way. Series or parallel. Well done, Rosa. Rosa 4321. The ammeter is always in series. Always, always, always. And then we're going to have 3 light bulbs. There you go. We are not going to make our life more complicated, yeah? I know that this X is very ugly, okay? I'm aware of it. You don't need to remind me. This X is horrible. It's horrible. But it is what it is. I'm tired. It's 9:15, okay? Parallel is the voltmeter. Yes, the voltmeter, you can set it up for 1 light bulb, for 2 light bulbs, or for the 3 light bulbs. Okay? You can set up the voltmeter parallel to the light bulbs, to 2 of them, or to the 3 of them. It's up to you. Okay? The voltmeter is measuring the potential difference. And you're like thinking like, oh, I don't know this potential difference. Okay, never mind. Have you seen this advertisement where you have a very ugly skinny fella? You know the advertisement I'm talking about? This ugly skinny fella, and then next to it is an advertisement that appears now, a super handsome and strong fella, and it's the gym advertisement before and after. Yes, so that is what the potential difference is measuring. How much energy the particles had before entering in somewhere, and how much energy they have after entering in somewhere. So if I put a voltmeter in here, let's say I set it up here, okay? What this voltmeter is measuring is how much energy the particles they had in here, how much energy the particles had in here, the difference between those 2 points. Why is that important? Because those light bulbs, okay, they don't lit up because of magic. They light up because the electrons, they transfer energy to the light bulb. Transferring. Like I'm sending you money. Transferring. Alright? So when the electrons are flowing, they transfer energy to the light bulbs. And the voltmeter is measuring the difference between how much energy they had before, how much energy they have after. That's why it is called potential difference. A difference. Okay? And how can we set up the same but 3 light bulbs in parallel? Easy peasy. genuinely exquisite. There is nothing infinite apart from God's love towards you. That's the only infinite thing. But in physics and in science, there is nothing infinite. Okay? Only God's love is infinite. We set our ammeter. And now we have our light bulbs. And now how they look like. Now they are parallel to each other. You see? Series next to, parallel in front of. And now, what is best one? What is the best one? What is the most useful setup? Parallel. Much more useful. Mainly 2 reasons. Reason number 1. A parallel one, if I now decided to go with my scissors and I cut in here, these 2, they will still work. However, in series, if I cut in here, the whole circuit stops. Any gap in any point will stop the circuit. Meanwhile, in here I could cut one of the branches and the other 2 will still work. And reason number 2. The resistance in parallel is always smaller. And you might be thinking, and why is the resistance smaller? Why low resistance is something good? Let me ask you one thing. We have been here for 45 minutes. How is your computer at this point? Is it hot? What will happen to your computer if you put it over your legs? It's gonna get warmer, right? And if you prolong that over the time, your computer meow goes to blue and it stops working. Why? Because nothing related with electricity works better with high resistance. It's not something good. If something has high resistance, meaning that it's very difficult for the electricity to flow. So what we want is lower the resistance to the minimum possible. That's why parallel is much better. That's why this computer is working in parallel. Those lights over me, they're working in parallel. Your phone works in parallel. Everything works in parallel. Oh, that's quite interesting. The energy wasted as a heat is very difficult to find an useful way, because it is very difficult to then use it for something useful. For example, I know you are charging your phone during the night, and when you wake up, your phone or your charger is hot. How could we use that energy in something useful? There is not many ways. Okay? It would be unbelievable. It would be great if we could use all that energy wasted, or not wasted. Well, yes, you can use wasted, but the best term is dissipated. It would be great if we could use the dissipated energy for something useful, but at the moment, with the technology we have, is not possible. Rosa, answering your question, what works in series? As much as I'm aware, at the moment, only 2 things. 2 things. Christmas lights and bombs. That's all. Okay? And why bombs? Because we don't care. They will explode. So what is the point of having low resistance? There is no point, right? Oof. Okay. Guys, I know that in the title it says we're going to talk about radiation, but we have been here for almost 50 minutes and it is 9:23, so I'm actually concerned about your sleeping time. Okay, so we're gonna leave it in here today, and tomorrow we continue with more, and I will start from radiation, so I don't disappoint people. Okay, tomorrow we continue from radiation. All right, but all of you should go to the bed as soon as possible. Tomorrow we have more learning, more school, more fun. Okay? Can I construct vectors? Yes, I can do vectors, of course. I will keep in mind, and next stream we do vectors. Okay? Hello, Kai. Great to see you. I think you joined just at the end, unfortunately. But tomorrow, more fun, more streaming, more learning. Take care, guys. God bless you. I'm going to watch a bit of anime, sleeping, and then bed. Bye-bye.